Thank you, sir. And I request Professor Agarwal to extend a floral felicitation to our keynote speaker, Dr. Ashwini Agarwal, Director, Applied Materials India Private Limited. I request Professor Agarwal to extend a floral felicitation to Dr. Arpan Paul, Chief Scientist, TCS Research. Thank you, sir. We also welcome Dr. Abhilasha Gaur, COO, Electronic Sector Skills Council of India, and Mr. Amrit Manwani, Chairman, Electronic Sector Skill Council of India. Thank you very much for your gracious presence. Ladies and gentlemen, our keynote speaker, Dr. Ashwini Agarwal, is Director, Government Affairs at Applied Materials India. He has a rich and diverse experience in handling enterprise and government segment for the tech-intensive ESDM sector. At Applied Materials, Dr. Agarwal handles the government affairs, which covers the public policy, programs, and market development initiatives relating to high-tech electronics, including semiconductor electronics and solar. He is an industry veteran of over 30 years of experience. Dr. Agarwal is a board member for Electronic Sector Skill Council of India and has chaired technical committees in solar and semiconductor domains. As a subject matter expert for solar skills at Electronic Sector Skill Council, he has contributed to the shaping of national occupation skill standards in these domains. He has a seminal contribution to the semiconductor policy inputs for the industry. Dr. Agarwal has authored a book on novel netware and has several industry white papers as well as peer-approved research papers to his credit. His thought papers, Jumpstarting Electronics Roadmap 2018-22, shaped National Policy of Electronics, Fabless Design Linked Incentive Program, and Specs for Semiconductor Components and Equipment. We're honored to have you here with us, sir. I request Dr. Agarwal to proceed with his talk titled Enter the Tornado, Scaling Sensors for a Smarter World.
Thank you, Katie. Thank you, Dr. Agarwal. And thank you, my dear audience, students. Let me see if I can get this off the road. So first key message is simple. Wake up. You had a heavy lunch. I did. So how do you put the lights on? Is it black screened? No? Okay. Let's turn on the show. Okay, thank you. We got the PC to wake up and a message to everybody. Guys, wake up. Okay, there's a world to change. Kitty is doing something brilliant. I know some of you are doing projects which are absolutely brilliant, and engineers can change the world. So, I look at it, there's a lot of engineering energizers that you will have. And here's one quick engineering fix we have, where I would like all of you to link back to me. So if you've got your phones, to keep them out, and you'll get my QR code linkage back again. And there are some very nice videos on semiconductor packaging, advanced semiconductor packaging, and content that you can get when you take the links. And really, linking is all that life is all about. So come back to it and let us start the session. I named the presentation Enter the Tornado after Geoffrey Moore's book, where he actually pointed out that there are certain technologies which mature and reach a point where they take the market by storm, and they really start scaling up in a way which is unimaginable. I think sensors are reaching that particular stage very clearly, and they are a key part of the world that is evolving. So if you actually take a look at the evolving era, it's the AI era, and it's actually considered as the fourth wave of computing. You have had the original wave of computing, and then you had the mobiles coming in, and today you have the IoT wave. And the next wave is actually when IoT wave moves to the actionable insight wave, where you have the artificial intelligence creating applications for humans, and being very, very sensitive to what is happening and getting almost to a stage that they can operate on their own. And that is actually creating a massive explosion of opportunity for the tech community. So if you take a look at it, 2018 was a very interesting turning point. Just before the COVID pandemic, you actually reached a stage where machines had crossed humans in generating data. And today, machines are fast outpacing humans in generating data. And they have reached a stage where you can actually use the machines for actionable insights. I heard Devendra ji in the last presentation actually talk in terms of what uh, anyway, let's just go ahead. So basically, he talked in terms of the industry 4. He talked of 5G, and he said that 5G is something which he's working on, and it's actually creating an era where new genre of applications will come in for humanity, and that is going to create a huge opportunity. But 5G is definitely a game changer, but it is still the it's just setting the tone for the 6G. 5G is reaching a stage where you are actually talking of connecting and computing. But 6G, the world is going towards, is actually going to create action-level insights. You're going to see it arrive in the era of 5G, and it's going to take off in the next generation in a massive way. This is an era where the computing will be actually driven by what we call ICAPS at my company, Applied Materials. IoT, communications, automotive, power, sensor, packaging. These are the technologies which will actually shape the future of the world. And it's actually going to be a crazy amount of growth. My agenda is going to be something like this. I have going to do a quick, introduction of my company, get you into, after the introductions are over, a quick view of the sensors, the way they are going, and then I'll get into more details on the material innovation that takes place at my company, the manufacturing portfolio that my company represents, and how this can be looked at for the future. So, strictly speaking, I don't know, how many of you heard of my company, Applied Materials? Raise your hands. Okay, good. Let's take anyone from this side. Just whoever raised the hand. I want to ask you a question. What did you hear? What do you know about Applied? No volunteer. Huh? Okay, so let me tell you, what is Applied Materials? Applied Materials is it doesn't make materials. It makes the equipment that makes the materials. As the world's largest equipment maker for the semiconductor and display industry. Okay, people who know the company, they say when you see Intel inside, Applied Material is the company inside Intel, and nearly 60% of an Intel factory would be full of applied tools. We are the largest tool maker for the semiconductor industry. The world's number 2 is a European company called ASML. They'll have about 25% footprint in an Intel fab, which means that the rest of the industry is in the last 15%, or it competes with number 1 or number 2. See, what they make, we don't make. What we make, they don't make. So really speaking, it's a very strong footprint that Applied has in the semiconductor industry. Uh, Put it in a different way, there's not a single chip in this world which would not have been touched by an applied tool in its production cycle. And that is our position in this particular industry. A 60-year-old company driving the Moore's Law as you hear about it, and a very strong footprint and technology owner for the semiconductor industry. So in this industry, really speaking, The tool maker has a lot of IP also to understand and clarify the applied position. Uh, we make the saw until we make the chair. But it is our saw on which that chair is made, and our tool on which that Intel has a design that it makes the chair on. And the process IP for it is owned by